us. Wait for another 2 minutes. Okay. As usual, take the attendance first. Okay. Okay, so let me take your attendance. Abdullah here. Abdullah, yeah. Ichin,
Yes.
Ichin's here. Farah, not here. Farah, not here. Forestia, Forestia's here. Hui Mi,
Yes.
okay. Izar's here. Aris,
Yes.
Shaiki, not here. Oh, okay, it's joining. Hold on. Okay, Shaiki, yeah. Praveen, yeah. Rauda, not here. Marwan,
Yes.
Marwan is here. Shinho, is here. John?
Yes.
Okay, good. Abdullah not here. Abdullah's not here. Okay, then let's good morning. So let's start our lesson. So after weekend, I hope you are energetic.
Yeah.
Okay. So we are in the second part of the second topic. Okay. So far what we learned in measurement techniques, we learn about all the instrument, how many decimal to write, and finally we went for the systematic error and random error, then we stopped there. Okay. So a small recap, instrument got two types, analog, digital. Analog, the precision, the uncertainty must go for half of the smaller scale. Digital, the uncertainty must go for smaller scale. Okay. And systematic error, random error. Random error is what? It's a type of error which has a different magnitude and sign. Can be +2, can be +3, sometimes can be -2 or -3. A systematic error is a fixed pattern one-sided. Yeah. So in this slide, you can check here. So comparison of the both random and systematic error. So random error causes a poor precision. Poor precision means what is meant by precision? We will get to know precision is the degree of closeness from the mean value. Sorry. Precision is the degree of scattering from a mean value. Okay. precision. So random error is a poor precision, never really concentrated. Okay, they really spread, like the diagram here. The random error, random error causes a precision. The orange color is the true value, but the values are scattered. Okay, scattered for precision. And non-specific causes, of course, it depends to the person. Okay, not reproducible. You can't repeat the same pattern every time. It's going to vary, so it's not reproducible. You can't produce it back. Okay, the error. If you got +2, again you repeat, you won't get +2, maybe +3. So it's not reproducible. Example is parallax error, as we told you. I told you earlier. Okay, systematic error, poor accuracy. It's very bad in accuracy. Okay, more dangerous, as I told you, like in the medical field, very dangerous. So there is a definite cause. We can identify it. Maybe kind of setting, okay, in the machine. Zero error, you have to subtract it. It's reproducible. Okay, reproducible means every time you take reading, it's going to appear. Okay, so we want to see Abdullah here. Okay, so okay, so please remember the two facts about random error and systematic error. Okay, so systematic error is totally deviated from the actual value. Okay, so now I'll talk about precision. What is meant by precision? Yeah, that refers to the extent or limit of sensitivity of a given measuring instrument. Or we can say the definition is a degree of closeness of several measurement of a quantity. Please add something here about the mean value. Please add this about the mean value. Okay, that's the second point. Degree of closeness. How close is it? Precision. Okay. Yeah. Meter rule, micrometer. Of course, micrometer is said to be more precise gadget. More precise gadget. Okay, so if you give more number of decimal places, we say it's more precise. Not necessarily accurate, but precise. Okay, quite close to the mean value. Okay, never really spreads the reading. Okay, accuracy, as I said, what is that? It's degree of closeness of a measured quantity to its true value. Okay, class, I think there is a mistake. Precision should be degree of, what do you call? Degree of close, you can say degree of scattering to be better. Precision, degree of scattering about a mean value. Accuracy is degree of closeness about a true value, actual value. Okay, accuracy. Again, repeat back. So what is precision? The degree of scattering. Put it as a degree of scattering. We don't want to have the similar wording. Degree of scattering about a mean value. Mean value. Accuracy is degree of closeness about actual value. Okay, actual value. Okay, so highly accurate measuring device will be provide measurement with close to standard. Okay, yeah. So accuracy. To have yeah. So these four diagrams tells accuracy and precision. Okay, the y-axis probability of density means how many times you repeat it, how many times you get that value. Okay, let's say the high peak value tells this is maybe you repeat it many times, 100 times, maybe for 10 times you get the peak value. Maybe 5 times you get this value. Okay, different number of times you get that value slot. Okay, so the first dotted line is the actual value. Okay, but the next dotted line inside the bell graph is the average value, the mean value. Okay, how much mean value deviated from the actual value is measures accuracy. Okay, more greater the mean value away from the actual value, accuracy is more deteriorates. Precision depend to the spreading of the reading. Okay, how much the reading spread. More spread it is, more poor precision. Okay, more poorly precise. Okay, the first diagram is very poor accuracy because measurement what do you call, the average is quite further away from the actual value, and poor precision too, because quite spreaded. The second graph here on my right is still poor accuracy, because mean value is quite away from the actual value, but precision is quite better. I can say high precision compared to the first one. Okay, not really spread. And the third one, quite a good accuracy. The mean value you see is quite close to the actual value. Quite a good accuracy, better than the other two. Okay, and precision is still bad. Okay, it's really spread. Okay, and of course the last one is high accuracy and high precision. Okay, so repeat again. Accuracy affected by what? Accuracy is affected by systematic error or random error. Anyone? Accuracy is affected by systematic error. Okay. Precision is affected by random error. Okay. Put in your mind. Okay. This is another 4 diagram. So the first one is good, precise, and very accurate. Second one, precise. All are not scattered that much, but poor accuracy. Third one, of course, not precise, not accurate. Okay, I can say sometimes accurate, sometimes hit the target, compared to the fourth one. Accurate means sometimes hit the target, sometimes not. This one is both that. Okay. Okay, so that's first part of the topic. Okay, the second one is going to be something calculation. Okay, so now we're going to, as I said last time, when we write a reading, the plus minus, okay, if you use ruler, you write plus minus 0.1. Okay, for example, here, the uncertainty is the range of values within the measurement likely to lie. It's called uncertainty. The plus minus 0.1. For example, you see the reading here down here, 12.5 plus minus 0.9. What do you understand by this plus minus 0.1? So he read 12.5, but the reading could be from 12.6 to 12.4. That's what our understanding of the plus minus. It could be lie between the 12.6 to 12.4. Okay. So that's uncertainty. It's a range of value within the measurement likely to lie. Okay. So this measurement called actual uncertainty. Okay. The scale reading, the pointer reading. For analog instrument, we go half of the smallest graduation, only for analog. Okay. The measured value, any quantities can characterize by absolute uncertainty. Yeah. Number of significant figures. Okay. When you write these values here, this number must follow 2 rules. Okay. You have to follow 2 rules. Look at the 2 rule here, down here. The measure value must have same dp as the absolute uncertainty. Both reading, the 12.5 and 0.1, how many decimal place? Both are same decimal place. Both have to be same decimal place. Both are different decimal place, not allowed. If you write both different decimal place, wrong. For example, you write here 12.50 and here is 0.1, wrong. Have to be same decimal place. Okay, first rule. Second rule is what? The absolute uncertainty must be one significant figure. The error must be 0, one significant figure. Okay, cannot write two significant figure. For example, 12.5 plus minus 0.10, two significant figure, cannot. The error have to be one significant figure. Okay, so this is the 2 rule. Okay, so we need to really understand this by heart. Okay, let me go to the whiteboard just to explain some stuff. Okay, let's say you got 17.6 plus minus 0.02. Okay, is it a correct way of writing the uncertainty? Is it follows the 2 rule? The first rule, check the
No.
significant figure. Significant figure, is it 1 SF? So significant figure is 1 SF. So obeys the first rule. Second rule, same decimal place. So it's not same decimal place. So it never obeys the second rule. So you have to correct it. How do you write it? The one significant figure is fine. No need to change anything. So the digit have to alter. How do you alter it? How many dp is this? 2 dp. Therefore, your value also must follow 2 dp. So how do you write? 17.6. You put a 0 there. So 2 dp. Now correct. So both of them are 2 dp. Okay. So another one. So what is the 2 rule? The error must be 1 SF. The both value must be same dp. Okay. Another reading. 364. Let me give you one. 0.5. Okay. Plus minus 0.124. Okay. Please write it in a correct way of writing the uncertainty. Okay, first, my advice, adjust the error first. Make the error as one significant figure. So what is the error here? Uncertainty must be
0.1.
0.1. Good. Should be 0.1. Your value must follow the same decimal place with the error. So should be 3, 6,
4.
4, then
0.
1.
0.1.
0.1. Yes, 0.1. That's the correct way of writing. Okay, good idea. Eh? So what is the 2 rule? The error must be 1 significant figure. Both must be same decimal place, same dp. Okay, this is the 2 rule to follow. Eh? Okay, sometimes this can be a little confusing. Okay, when you get confusing, something like this. Let me show you another one. Eh? Let me clear this. Okay, let's see. 365.2 plus minus 9.81. Okay, this is a little challenging one. Okay, let's see. I give you 1 minute for all of you. Give me the proper way. How do you write this number with this proper significant figure and uncertainty? Okay, 1 minute for you. Uncertainty must be 1 SF. But here uncertainty is 3 SF. So you have to make it 1 SF. How much?
10. 10.
Okay, go for 10. It's okay. Okay. Okay.
Oh.
This one, how do you write? Both must be same decimal place. This here, this is the problem. Okay, anyone? Any suggestion? As we get collect suggestion. Anyone?
365.
365. Any other answers you feel should be logical? This is 365.2. Okay, one of you said 365. Any other answer you feel logical? I think can't be 365. Anyone suggest any other value you feel should be correct? Okay, yeah, this is the trap. Why it can't be 365?
Too large of
Too large values. Okay, because here you see how many decimal place? 0 decimal place, no decimal place, right?
Yes.
So here the value also you went for 0 decimal place. That's why you wrote 365. Okay, correct. But you see, whenever there is no decimal place, you try to see like this. Bring this 0.9, the point here, okay, to 2 places to the left. Just temporarily. If you bring here 2 places to the left, so what is the number going to change? 0.0981, right? Okay.
Yes.
So if you change here 2 decimal places to the left, this will do 2 places to the left. So it become what? 3.652.
6, 5.
3.652. Okay. Then times with how much? Because I shift 2 places, times with 100, right? Correct? Mathematically correct, right? Above and bottom. Now you do the adjustment. Now you got a correct answer. Okay. Try to simplify inside. The error must be one significant figure. So how do you write? This is one significant figure. How do you write?
No.
Write it in one significant figure.
0.1,
0.1. Here, what do you get?
3.7,
You get 3.7. Times the 100 inside, what do you get?
370 plus minus 10.
Good, correct. 370 plus minus 10. This is your correct answer. You can't go for 365. Okay. So you see, the rounding need to be done at 6. The 5 need to be rounded. Okay. So it becomes 370. 370. It makes sense. Plus minus 10, you can't go for 365. How you can read 5 ringgit? Let's say it's in your pocket. Let's say someone said, how much money you have in the pocket? You say 365 ringgit I have in the pocket, but I'm uncertain by 10 ringgit. If you are uncertain by 10 ringgit, how you can read the 5 ringgit? You can't read 5 ringgit. You can read multiple of 10, but you can't read 5, right? If it's plus minus, for example, another one, I say, how much money in your pocket? You say, I have 550 ringgit, but I'm plus minus by 100 ringgit. Does it make sense?
No.
It doesn't make sense, right? Sorry. It doesn't make sense, right? Because of what? You are plus minus by 100. So that means you can't read the 50 ringgit. You only can read multiple of 100. So the proper way of our writing is 500 or 600 plus minus 100. Okay. So to avoid this, if you have uncertainty with 0 dp, where you shift the 2 places to the left, then you can correct it correctly. Then you times in the 100 inside. So you got the correct answer. Okay, makes sense, huh? Any problem? Anyone? This is very important. Okay, this is very important. We're going to use this. Okay. Okay, so that's the rule. Go back. So 2.5, 0.1, the measure value has the same decimal place, must be one significant figure. Okay. Okay, now comes to the real problem. Okay. So generally, all readings can be recorded as R plus minus changes of R, uncertainty. There are 3 types of uncertainties we have circulating in your A levels. First one called absolute uncertainty. The one we're dealing just now is all absolute uncertainty, the actual number. Like this case, 2.05 plus minus 0.05. This 0.05 is actual or absolute uncertainty, call it. Okay. We have another type of uncertainty called fractional uncertainty. What is fractional uncertainty? Your changes of R over R is fractional uncertainty. How fraction is the uncertain? Okay. So for example here, for one example, 0.05, 2.04, what is fractional uncertainty? Changes of value of R. 0.05, 2.05, so it's 0.024. This is fractional uncertainty. Okay. So let's say if the fractional uncertainty get 1, means what? Let's say fractional uncertainty got 1, means what? The uncertainty is same as the value, like 2 plus minus 2. So fractional uncertainty is 1. It's a very bad reading. Fractional uncertainty should be quite small normally. Okay, third type called percentage uncertainty. Percentage uncertainty is just the fractional multiplied by 100% and change the percentage 0.024 times 100 to get percentage uncertainty. In Cambridge, out of these 3, the most common one they will ask is the third one, percentage uncertainty. Second common one they will ask is absolute uncertainty. fractional very rare. So give importance to percentage and absolute. Okay. Yeah. So absolute, fractional, percentage. Three types of uncertainty you have. Okay. Changes of R, changes of R over R, changes of R over R times 100% is a percentage. Okay. Okay. So now, what is this? Okay. It's combining uncertainties. Call it. What is meant by combining uncertainties? You have two measurement, B and C, let's say, and A equals to B and C. Okay. For example, let me go to the whiteboard a little. Okay, let me clear this. Okay, let's say your first reading is 2.4 plus minus 0.1 cm. Okay, you have another reading. Okay, it's 5, 2.5. This is 2.41 plus minus 0.02 centimeter. You have two readings. You want to find A. A is found to be B plus C. Okay. So this is the problem now. The B and C is obtained from instrument. Let's say we take it as a raw data. Let's say it's a raw data. So you want to find a new reading A which linked to the raw data is B plus C. So what is the value of A? What is the value of changes of A? Okay, A no problem. In this case is 2.5 plus 2.41. So how much is that? It's 4.91. So A no problem, just simply add them. But how about the changes of A? How do you find changes of A? Changes of A, the uncertainty of A is dependent to the uncertainty of B and C. This is called addition. Okay, addition. So there is a formula to follow. Okay, if A is B plus C, the uncertainty of A is uncertainty of B plus uncertainty of C. This is a formula you need to follow. Okay. So A, B plus C means uncertainty of A is uncertainty of B plus uncertainty of C. In this case, what is the uncertainty for A? Uncertainty of B, which is uncertainty of B, which is 0.1 plus uncertainty of C is what? 0.02. So what is the uncertainty overall? 0.12. This is uncertainty of A. So write the answers for both A and changes of A and changes of A, sorry. So changes of A, you can't write 0.12. Why? Two significant figures. How do you write it? 0.1. And your A is how much? 4.91. How do you write? Anyone? Anyone? How do you write? Same decimal place, right?
Yes, 4.9.
But here, how many decimal place is this? This is one decimal place. So here also must have one decimal place. So 4.9, correct? 4.9. This is how you write. Okay, so the point here is if A is B plus C, the uncertainty of A is changes of B plus changes of C. Okay. Okay, now we're going to do if A is B minus C, how the uncertainty of A going to be? They say follow the same formula. For plus minus, uncertainty of A is uncertainty of B plus uncertainty of C. Same. Uncertainty always will be added. No such thing as uncertainty reduces. More data you include in measurement, the uncertainty become more bigger. So uncertainty formula always plus. Okay. So this is for plus and minus. Go back to the screen now. So for this is combining uncertainty. Combining means the B plus C combining two data. Okay, combined to form a new one. Addition, subtraction, always A plus B, A like B plus C, changes of B, changes of C, like just like this diagram. Okay. So the first one, Z equals to A plus B. So uncertainty of Z is changes of A, changes of B. This plus or minus is going to be changes of A, changes of B. Okay. So this happens for addition and subtraction. This is addition, subtraction. Okay. Another group of data is which is little complex, multiplication and division, times and division. Okay, like this. This one, third one. We go for the third one first. Z equals to AB, A times B. How's the uncertainty for it will be? Changes of Z equals to changes of A, changes of B, but over Z, over A, over B. If it's times. Okay. If it's times, just put it over the value, over the A, over the B, over Z. On top is the same. If Z equals to A divided by B, same formula. So multiplication, division, same group. The uncertainty going to be the same formula. Just over Z, over A, over B. Got it? Okay. So for example, I say A equals to, okay, like for example, volume. Volume equals to length times the breadth times the height. What is the uncertainty in the volume? So what is the uncertainty formula you write? Anyone? What is the uncertainty formula for the volume? Changes of V over V equals to changes of L over L plus changes of B over B plus changes of H over H. This is the uncertainty formula because it's times. Okay, this is the uncertainty formula to find changes in V later. Okay. For density is what? Mass over volume. What is the density formula? Changes of rho. Anyone? Come on, give a try. What is the density formula? Changes of rho equals to changes of
N
over
over
M plus
changes of V.
V over V. Good. Yeah, this is how it works. So if it's divide or if it's times, it's going to be over the values. Okay. If it's A equals to B plus C minus D, then what is the uncertainty for the A? Will be, anyone? Changes of B, changes of
C.
plus or minus? Changes of D, plus or minus?
Plus.
Always plus. Uncertainty always added. You put minus from for uncertainty. To find the value of A, yes, you need to minus, like you follow the formula. But when you want to find the uncertainty for A, all plus. Okay, good. Okay, so these are the formulas. We go to the last one. Last formula. We have few. Another formula is this one. This one first. Look at this. Z equals to A power of M, B power of N. If we got power, the quantity which has uncertainty got power, then the formula is going to turn to become like this. If you have power of M, it's going to be like changes of Z over Z, changes of A over A, changes of B over B. The power will get down. So M changes of A over A, N changes of B over B. Okay, if you got power. Okay. So, for example, like again, for example, like V equals to V squared equals to period equals to 2 pi root of L over G. Okay, this is the formula for pendulum oscillation. For pendulum swinging, the period is found by using this formula. Okay, what is the uncertainty formula for period? Come on, anyone? The length found to be got some plus minus changes of L. The gravity it seems got some changes of G, but 2 pi is constant. 2 pi is constant. Constant means you don't have uncertainty. So constant won't involve in uncertainty formula. Okay. So anyone give a try. Changes of T over T. Of course, it's going to be over T because it's in terms of times and division. So it's going to be over T. Anyone can give a try? Can be what? Yeah.
1 over 2
Very good. 1 over 2.
times
Yeah.
change in L over L
Change in L over L plus.
plus 1 over 2 times change in G over G.
Very good. Yeah. Perfect. Okay. So half, because the power is square root, so it's added as power of half. So the half will get down. So you get this is the equation for your uncertainty. 2 pi won't involve in uncertainty formula. Any value, no uncertainties won't involve in uncertainty formula. Okay. Let's say they're asking for find the T and changes of T. Okay. If L and G value is given to you. So T, to calculate T, you have to use this formula, of course. To calculate T, don't ignore 2 pi. You have to use the exact formula. 2 pi root of L over G to find the T. But to find the changes of T, you use this formula. The 2 pi won't involve. Okay, makes sense. Okay, this is the dominant one with power, with division and everything. Okay, okay, another one, last one. Let's say you have a formula like this. T equals to this, I don't want to put T. Okay, let me put a AB, easier. Okay, A equals to 5 root of B. Okay, root of B, yeah. What is the uncertainty formula for this? B as the uncertainty. So changes of A over A equals to, anyone?
Half.
Half changes of B
B
over
over
B. Yeah, correct. B over B. So this. So the numbers won't involve in uncertainty. Okay. Okay. So this is the rule for you to calculate. Okay. This is the common formula with in terms of AB, but they're going to use physics formulas to calculate it. Okay. Okay. So we're ready for questions. So this is the all the rules. You can see everyone can see the PowerPoint, right? Okay. So these are the all rules. Okay. Okay. So now one question. We're going to use the rule now. Okay. Whenever you want to find uncertainty, when there is a 2 or more raw data involved, first thing you must do is write an equation. Second thing, you write the uncertainty formula, then you find the answer. Okay, for example, here, there are 2 raw readings here, R1 and R4. Object measure yields the following readings. R1 is 20.55, okay. R4 is 0.05 uncertainty because the pointer reading. What is the length of L? Okay, so we know. So write a formula first. Try to make an habit to write a formula because it's useful. Okay, so we introduce the quantity. We say the L is R4 minus R1. This is important. Write the formula. L equals to R4 minus R1. Link the formula with the raw data first. Okay, so L equals to R4 minus R1. So it's 2.45. So changes of L is what? Changes of R1 plus changes of R4 because it's equal to A equals to B plus C format. Therefore become 0.1. So final answer is 2.5 plus minus 0.1. And this is the rule why I'm saying pointer reading half of the smaller scale. But if you 2 places uncertain, the error added because A equals to changes of A equals to changes of B plus changes of C. The error will be added. Okay. So write a formula. If formula not given, come out with a formula. If symbol is not there, create your own symbol. For example, here see length, put it as L. Up to you. Okay, create a symbol. Okay, this is the final thing, but I skip this. We still not done with the uncertainty yet. Okay, this I skip first. Okay, before we go to this, Okay. Look at this one. One example. Is it the working make sense? 1 minute for you to digest the question and answer. In an experiment, the external diameter D1 and the internal diameter is D2 are found to be 64 and 47 respectively. What is the percentage error in D1 over D2? So my advice, write a formula. So let's say the thickness is T equals to D1 minus T2. So it's 17. That's your T thickness. What is the error in the T? Changes of D1 plus changes of D2. So it's 3. So the answer is thickness is 17 plus minus 3. So percentage uncertainty is 3 over 17 times 100%. So 18% uncertainty. Okay, this is just minus. Okay, let's continue. Okay, now here I show you this formula. Okay, sorry. Okay, look at this question. The formula period is 2 pi root of L over G. So such a pendulum is in determine G. The fractional error in the measurement T is X. What is meant by this? Fractional error in the period is T is X. This X is what? Changes of T or changes of T over T or changes of T over T times 100%. This X is what? Fractional uncertainty. Fractional uncertainty means this should be changes of T over T is your X. Changes of T over T. That's a mistake. Oh, there is a mistake in this diagram. I think it should be the other way around. You see the calculation here? Changes of T over T, they put Y. Y, sorry, there is a mistake. Here T should be Y. It's Y. The L should be X. Okay, please change this. T is Y, L is X. Okay. So fractional uncertainty means changes of T over T. Changes of T over T is Y. Fractional uncertainty for L is Y. X should be X. So changes of L over L is X. The question is what? What is the fractional uncertainty for G? So remember, if they're asking for uncertainty for G means make the G as the subject first. Make the G as the subject first before you write the uncertainty formula. Okay, this is important. If the question is about G and G is not the subject, make sure change the G as the subject first. Okay, then write the uncertainty for this. Changes of G over G is changes of L over L, 2 changes of T over T. Make sense? T got square, so it's become 2 changes of T over T. L no power, so just changes of L over L. 4 pi squared does not involve because it's constant. So this is your uncertainty. So changes of G over G is the one we are looking for, right? Fractional error. Fractional error is changes of G over G. Just changes of L over L is X. Changes of T over T is Y, so it becomes X plus 2Y. So this is your solution. This to find fractional error. Okay, this is to find the fractional error. Okay, any question from here? Anyone? I hope you digest well this part. Okay, let me do one question. I give a chance for you to do a question by using this knowledge. I go to the pass here, one pass here. Please stop the PowerPoint first. We go back to the questions. So everyone can see the question. Okay, this is one pass here. We go to the all percentage. You want to go for percentage? Okay, this one. Okay, everyone, please look at Juno 5, question 4. Okay, use the technique I taught you just now. Try to get the answer for this. 2 minutes for you. Okay, 2 minutes for you. So it's in an experiment radio control takes car. Car takes 2.5 seconds and 40 meters to travel. What is the car average speed? So remember what I told you? First, get the formula. If you don't have symbols, you create your own symbol. Okay. Second, write the uncertainty for that quantity. Then you're done. You can get the answer ready. Okay. So this is speed equals to speed. So what is the formula you're supposed to use? Speed equals to distance over time. Okay, so that's the formula. So use that formula. S equals to maybe D over T. Put a symbol. S equals to D over T. Okay. So looking for what? You're looking for S, the speed, with its uncertainty. What is the uncertainty formula for S? S equals to D over T. Anyone? Changes of S over S equals to? Anyone? Changes of S over S equals to?
D over D.
Changes of D over D plus changes of T over T. Okay. Okay. So anyone can give me the answer? So what is the 4 answers here? Okay. What are the 4 answers is there? Is it C or is it D? Okay, let me open up the whiteboard. So S equals to what? B over D, sorry. S equals to distance over time. So you're looking for S plus minus changes of S. So what is the uncertainty formula? You must write for S. So it's going to be changes of S over S equals to changes of D over D times, plus changes of D over T. Okay, so hope everyone got this formula. Hope everyone done this equation. You must get an equation. Okay, the first one, first step. Second, write the uncertainty formula. Okay, now find for me the changes of S. What is the changes of S you get? Substitute the D, changes of D, G, and the S. S also you need to bring here to the right to find the changes of S. How much? Anyone got changes of S? I go back to the question.
0.36.
So the changes of S, you got 0.36.
36.
S, what do you got? Changes of S 0.36. S, you get how much? You got 16.
16.
16. So 16 plus minus 0.36. But anyway, I go back to the question. What is the answer should be? Which one is the answer?
Donkey.
Is it D?
C.
C.
C. C. C. C.
C, yes, good. It's a trap, It cannot be D, right? Although you got D is the answer, but you can't go for D, right? Why? Because uncertainty must be one significant figure. 0.36 is two significant figure. 0.36 you have to round it to one significant figure. Check both of them same decimal place. I think best goes for C. The answer is C. Okay, any problem here? This is the preliminary one, quite a basic one. What do you have to do whenever there is uncertainty question? First, you must do what? Write the formula. If formula is not given, write a formula. Symbol not given, write your own symbol. Just now I write like S equals to D over T. I create symbol. Then write the uncertainty formula. Then get the answer. Okay. Okay. So now let's go more questions. Okay, I go from the beginning. So June 02, question 5. Question 5, the power. 1 minute for you. Just give me the answer straight away. The power loss P in a resistor is P equals to V squared over R. Cambridge this time is quite kind. They show the formula. Sometimes they won't give formula. They expect you to find a formula. Okay. This case good. You have the formula. The uncertainty of the V is 3%. The uncertainty for the R is 2%.
C.
So how many percent is uncertainty for the P?
8%.
8%. Good. Those who got very fast, 8%. Yes, good. It's 8%, right? So what is the uncertainty formula for P? Anyone? Changes of P over P equals to
2 times changes of V over V.
E plus changes of R over R. Good, yeah, changes of. So 2 times changes of V over V. Changes of V over V, okay, I need to show you this, okay? So please remember the V is 3%, R is 2%, okay. So I'll show you this, okay, P equals to V squared over R. So changes of P over P equals to 2 changes of V over V plus changes of R over R. Okay, I hope everyone got this equation correctly. Okay, now whenever they say percentage, you no need to find the changes of P. You just change them to all multiply by 100%. This multiply by 100%, sorry. So therefore here also multiply by 100%. All are multiplied by 100%. Left 100%, right also 100%, right? Mathematically should be correct. Okay, so we are looking for changes of P over P times 100%. We are looking for this changes of P over P times 100%. Percentage uncertainty for the P. So it's same as 2. What is this? This is what? This is percentage uncertainty for the V, which found to be 3%. Okay, so straight away you can use 3%. Changes of V over V times 100% is 3%. Don't put in your mind that you need to find the changes of V. Changes of V over V times 100%, we know already, it's 3%. Straight away we put 3%. Easier. Changes of R over R times 100%, this one is going to be another 2%. So altogether is 8%. So power as a percentage uncertainty of 8%. So now tell me, which question look easier? Actual uncertainty or percentage uncertainty? Which is easier? Actual or percentage? Just now you did actual one. Actual you need to calculate for, just now you know the speed equals to distance over time. You need to calculate for changes of S and S separately. So this is more harder, more work, more tedious. Percentage is easy. Okay, just both sides 100%. Get the formula, get the uncertainty formula, both sides times 100%. The 100% packed together change to percentage. Okay. Okay, we go more about this. So this case, the question 5 is 8%. Okay. We're going to do more about this. Okay, this is the challenging one. I come back to this after we done few. Okay, this one. 1 minute for you. Come on, get the answer. Question 4. A thermometer. Thermometer can be read an accuracy of plus minus 0.5 degrees Celsius. This thermometer is used to measure temperature rise 40 become 100 degrees Celsius. What is the percentage uncertainty in the measurement of temperature rise? One minute for you. My advice, write a formula. Temperature change, give a symbol. Temperature change, maybe you can give a symbol. Maybe theta. Maybe you put, okay, A is the temperature change. So write a formula. A equals to B minus C. B may be final temperature. C may be initial temperature. Then write the uncertainty formula for A. Then you can find the question looking for what? Percentage uncertainty. Percentage uncertainty, if I give a symbol for temperature rise as A means percentage uncertainty looking for what? Changes of A over A, or changes of A over A times 100%. You're looking for what? Anyone? You're looking for changes of A over A times 100%, percentage uncertainty. So that's the clue. Get the formula. Has anyone got the answer? Nobody. So let me go to the, B. Let me go to the whiteboard. So initial temperature is 40 degrees Celsius. Final temperature is 100 degrees Celsius. The uncertainty is 0.5. What is the temperature difference? So first, what my advice? Write a formula. Okay, temperature change. I write A maybe. This I symbolize as the temperature change. Temperature change. Temperature change. Okay. Temperature change now. The question looking for changes of A over A times 100%. Decide what is the question one. Okay. So A is equals to what? Final temperature minus the initial temperature. I wrote a formula by using my own symbol. But I'm looking for this. Okay. So write the uncertainty formula for A. So changes of A is equals to what? Changes of final temperature plus or minus plus changes of initial temperature. Okay. So this is the uncertainty formula, second level. Got this? Good. So changes of A how much? Anyone? 0.5 plus with 0.5. So changes of A how much? 1. So what is the final answer here? Changes of A is 1. A how much? What is the A value? What is the temperature difference? Final temperature is how much? 100. Initial how much? 40. So temperature difference how much? 100. 60. So this is your A. That's your A. So 1 over 60 times 100% is your final answer. How much you get? 1.7%. Okay, this is what I expected in your working. First, get a formula, very important. Get a formula. Use your own symbol, whatever symbol you like. The changes in temperature is theta minus final, or changes in temperature is B minus C, any symbol. But you should know the symbol represents what. The final check, you are looking for changes of A over A times 100%. So you form the uncertainty formula, you can get that. Okay, any problem with this working? You get the idea?
Yes.
Yes, okay, so we're going to strengthen this. We're going to do more. We already done with this topic. Now this is the last part. Okay. Okay. So more questions? Okay, this one. Give me the answer. Okay, I want your feedback. I call your name, so you give me the answer because I don't know. Some of you got the answer or not. Okay. So first, spend 2 minutes first. Then maybe I'll call one of you. Maybe you can guide me how to write on the whiteboard, what formula and everything. 2 minutes, get me the answer. Write the formula, get the uncertainty formula for the equation. Then check, are you looking for changes of that number value? Like this case, what? This case, power. You're looking for changes of P, changes of POP, or changes of POP times 100%. Decide that first. In this case, you're looking for changes of POP times 100%. Okay, what is the formula linking to this? Anyone?
G
Yeah, P equals to
Square.
what formula? P equals to I squared R. Good. So the formula must come to your mind in this case is P equals to I squared R. So second, write the uncertainty formula for P. Write the formula. Uncertainty formula for P. So changes of P or P equals to anyone?
two changes of I per I.
Okay, very good. Two changes of I over I plus
Changes of R over R.
yes, changes of R over R. Changes of P over P equals to 2 changes of I over I plus 2 changes of R, changes of R over R without 2. Okay, you are already there, 70% done. So now what do you do? You want to get percentage uncertainty. So therefore, left and right all times with 100%. Then you are almost done. You can get the answer for the P already. But now here, when you put changes of I over I, I was in milliampere. Do you need to convert to ampere?
Yes.
Is it necessary or no need?
No need.
No need. Why? Because changes of I in milliampere, I also in milliampere, they cancel. So it's a good news. In a fractional uncertainty, you no need to change. Okay, just leave it as milliampere, 0.05 over 2.5. Simple. You change to ampere also, the fraction going to be same. Okay. Changes of R over R. But you see the way they wrote is they just put 2%. Is it a good news or bad news? It's good news, easier. Changes of R over R times 100%, you just replace as 2% straight away. So what's the final answer? Okay, so changes of P over P equals to 2 changes of I over I plus changes of R over R, all times with 100%, 100%, here 100%, here also 100%. So we are looking for this, okay. So 2 changes of I over I times 100% is, okay. Anyone, what do you want? Are you forgetful?
0.04.
0.04, yeah, 0.05 over 2.5, right? Times 100% plus These changes of R over R times 100%, we know it's already 2%. So what's the final answer?
6%.
So 6%. That's how you do the working. Okay. First step, get the formula. You're stuck here, gone. You have to recall, you must get the formula. Second, you must know how to write the formula, the uncertainty formula. That's your final answer. Okay, so should get 6%. Okay, so we continue. We go to the tough one. I think you are ready for the tough one. Okay. So the answer for this is 6%. Okay, so we go to the tough one. Okay, this is the tough one. Think carefully before you give me the answer. 2 minutes for you. Question 5. You get this means your uncertainty is quite good. A student makes measurements from which she calculates the speed of sound as 327.66. She estimates that a result is accurate to 3%. Which of the following gives a result expressed to the appropriate number of significant figure? 2 minutes for you. Okay, so anyone got an answer? The answer is 3%. Which of the following gives the result expressed in appropriate number of significant figure? You say the final answer, the actual value must written as what? Is it 327.7, 328, 330 or 300? How many decimal place you need to write? Where you need to cut off? All depend to the error. Error how much? It's 3% of the value. 3% of 327.66 how much? 9 point something, right? But 9 point something. Okay, follow the 2 rule. What is the 2 rule? The error must be one significant figure. Change the error to one significant figure. Then modify the value to same decimal place as the error. Then you get the answer ready. How do you supposed to write the actual value? So anyone?
330.
Very good. So hope everyone got the answer 330. It should be 330. Right? Okay, how it works? So 320, what is this? Okay, 327 point something, what is that? Plus minus 3% of this is how much? Sorry, let me check that question. 327.66, 66. 3% of this how much? 9.8. 9.8 is it? 9.8. I think so. Okay, this is the one I told you. It won't be no decimal places. So what you do? To be safe side, shift 2 places. So it becomes 0.098. Okay, shift these 2 places. Become 276. 2766 times 100%. Sorry, times 100, sorry. Then it's become what? Become 0.1. This become 3.3. Times 100. So you get 330 plus 10. The trap is here, the 9.8, 0.9, 9.8. If you still fix, you never change to the decimal places, you might start where to cut off the 327. This is the technique. Okay. So those who get 330 plus minus 10, you are almost good in uncertainty. Okay. Any questions from here? The answer is 330 plus minus 10. Okay. Okay, good. I hope everyone cope up with the development. More questions? We're done with this topic, eh? We're doing questions here and there. Okay, this one. This is November 5. Okay. I give you 1 minute only. You can. I hope you can do fast. Give me the answer for this. The density of the material of a rectangular block. Mass given, length given, breadth given, height given. The density is 2.5. What is the uncertainty in these results? Okay, what I told you? Write the formula first. Introduce symbol. Whatever symbol. Yeah, they want uncertainty for the density. So you're looking for changes of rho. So you must find the rho density formula first. So write the formula. Density equals to M over V maybe. But you can't use V. V you have to break into length times breadth times height. Okay. So anyone got the answer? The unit no need to convert. Centimeter, leave it as centimeter. Because the density also in gram per centimeter cube. So I call the name. Can you just give me the answer? Tejon, what is your answer?
I haven't calculated.
Okay. So write the density formula first. So what is the density formula you write? You put a symbol. Rho equals to maybe mass over volume, but volume you have to break to this length, breadth, and height. So maybe put volume is L times B times H. So M over L times B times H. Rho equals to M over L times B times H. One formula. Now write the uncertainty formula of the density. Changes of rho is what? Write it that first. Then you can find the changes of rho already. Okay. Primi, what's the answer?
I haven't finished.
Oh, okay. So take time. Give you another 1 minute.
Is it D?
D, yeah. So, okay, so 5D. Let me check. Number 5D. Number 5D. Number 5. Number 5. November 5, right? So it's found to be C, yeah. Number 5, right?
Yes.
Okay. Yeah, number 5 is C. So you should get C. Yeah. So should get C. 0.05. Get 0.05. What's the mistake? The density is 2.5, eh? Okay, so let me go to the whiteboard. So first, what do you have to do? Write the formula. So density equals to mass over volume. Not enough. You can't leave this because you must bring all the quantity there with uncertainty in this formula. So you better write mass times length times breadth times width. Okay, so this is the formula, right? Length and breadth times height, sorry. Okay, so H. So you are looking for what? Changes of row. You're looking for changes of row. Okay, changes of row. So what is the uncertainty formula? Changes of row over row by using this formula. So what? Changes of M over M plus changes of L over L plus changes of B over B plus changes of H over H. Okay, this the formula you should get, right? Okay. So you're looking for changes of row only. You're looking for changes of row. You substitute all the other values. Substitute all the values. The row you need to times later to the right to get the changes of row because your question is changes of row. So what do you get? So changes of row over row is what? 2.5. Changes of M over M is what? I go back to the question. So remember this is the step you have to use. So yeah, 0.01 over 5 over 2 over 1. 0.05, 0.01 over 5 over 2 over 1. Okay, go back. Sorry. Yeah. So mass is what? 1 over 25, right? Quite forgetful. 0.125. So this is 0.125. For what? For the mass. Key in everything. Key in everything. This is 0.01 over 5. 0.01 over 2. I think the other one is what I do here. 0.01 over 1, if I'm not mistaken. The unit no need to change. Centimeter, fraction, they cancel. So after you get this fraction times 2.5, you'll get changes of row. You'll get changes of row. Okay, this is the working. Okay, important is you must get the formula. So you get C here.
Yes.
You get C, so you get 0.05, right? Okay, so this is how the working going to be for uncertainty. Okay, So which step you got a problem here? You got problem with finding the formula, or it's a big issue. Right? The uncertainty, you can't stop at volume. Okay. So you must bring in all the L, B, and H here, then write the uncertainty formula, then substitute. Okay. Okay, now I'm going to give my questions now. Okay. So I'm asking you a question, you answer. Okay. There is one sphere. There is a sphere, copper sphere. Okay, copper sphere. The diameter. Okay, remember, the diameter. The diameter percentage uncertainty is 5%. When he measure, he found the diameter percentage uncertainty is 5%. The mass of the sphere is found to be 10% percentage uncertainty. What is the percentage uncertainty in the measurement of density? How much? Anyone? Diameter is 5% uncertainty. Mass is 10% uncertainty. What is the percentage uncertainty in the density? Anyone? One minute for you. Okay, class. So first write the formula. What is the formula?
Volume of sphere.
Volume of a sphere, yeah. Write a formula. What is the formula for density? Density equals to mass over volume. Is this enough to deal with this question?
No.
No, enough, because we need to bring in diameter, because diameter got 5%. So you have to bring in diameter. So rho mass volume is what? Volume for a sphere is 4/3 pi r cube, right? But still, is it good? We want diameter. We do want radius. So we do want radius. We have to reformat it back. So write what? M over 4/3 pi what? In diameter, you put d over 2 squared. So this is the formula you must come out. Okay. Now give me the answer. What is the value of this? How many percent? Write the uncertainty formula for density. Changes of rho over rho equals to what? Anyone? In terms of diameter and mass. Mass is here, diameter is here. So changes of rho equals to?
Changes of mass over mass.
Changes of mass over mass. Then diameter. So diameter is square one. A 4/3 pi, this over 2 all won't involve because they are constants. Only check the d square. So it's going to be
2d. 2 inches of diameter per diameter.
Okay. This is the formula. So what's the answer for this? All times with 100%.
17.5%.
17.5%. Is it? Mass, what is the percentage? 10%. So 10 equal class 2. Percentage for the diameter is how much? Is 5%. So 2 times 5. So finally, how much? 20%.
Why it's not 3?
So it's 20%. Oh, sorry, I made a mistake. What is the mistake? What is the mistake? It's power of 3, right?
Oh,
It's 3.
Oh,
So it's 3. Yeah. So yeah. So what's the answer? 3 now. Huh? So how many percent? 25%. Yeah.
Sure.
Yeah.
The percentage of the diameter don't need to divide it by 2.
No, divide by 2. You just D is power of 3. Power of 3 is going to be 3 changes of DOD. That's it. The 2 just to find density only. The 2 bottom here won't involve in uncertainty because it's a constant. Only focus to D with this power. D power of 3 only. So D power of 3 become 3 changes of DOD. No need to divide by 2. Okay. So it's going to be 25%. Any other questions? Anyone? So where do you start? I believe everyone got mass over volume. I hope majority must realize that because diameter is given here as a percentage uncertainty, you must bring in diameter in the formula. So those who brought in radius, still not enough. Radius have to convert to diameter. You must see the diameter. You must go to the diameter. And then you can see how the diameter density linked to mass and diameter. So now when you write uncertainty formula for the density, don't care about the constants. All constant won't involve. Just see the uncertainty values with this power. M, no power, so changes of M over M. D got power of 3, so 3 changes of D over D. That's it. Rho, changes of rho over rho. So for 3 pi, the over 2 for the D won't involve. Under uncertainty. Okay? Clear, eh? Okay, so I'm asking you another one question. Okay, this is more scientific. Okay, let me see. An object was dropped from a certain height. Okay, a student want to calculate the gravity. She want to measure gravity. So she did an experiment, or dropped an object from a certain height, the height h, and she measured the time. Okay, the h when she measure is found to be 5% uncertain. When she measured the time, it's found to be 10% uncertain. Okay, what is the percentage uncertainty in the measurement of gravity? 2 minutes for you. What is the percentage uncertainty for gravity? The height she measured is 5% uncertain. The time interval she measured is 10% uncertain. She dropped from rest. She dropped the object from rest. Ignore air resistance. Okay. 2 minutes for you. Give me that. What formula? First get the formula. Write the uncertainty formula. Then you can get the answer. Here formula not given. You have to figure out what. What's the formula? Anyone? Those who did your O-level knowledge, O-level or SPM knowledge. What is the formula can be used to find gravity here? Anyone? What formula? One of the kinematic formula. Anybody can recall? Height 5% answer. Height and time is needed to find gravity. Can you find gravity by using measuring the height and time? What formula do you use to measure the gravity?
Is it half GT squared?
Yeah, good. Yes, good. S equals to anyone? UT plus half AT squared. You have to use this formula, right? Because U is 0, 0. So the formula become Sx, I put H, so I put H now. So H equals to half, A is what? G T squared. So this is the formula must come to your mind. Can you give me the answer for the G? No? Write the uncertainty for G. Changes of G over G equals to what? Anyone? Changes of G over G equals to what?
Changes of H over H
Very good. Okay.
plus 2
Yeah.
times of change of T over T.
Very good. Yeah. This is the formula. So therefore, what's the answer for the changes of G over G? So this all are times 100%. So all 100%. So the changes of G over G is equals to percentage of H plus 2 times of percentage of T. So answer 5 plus 2 times of percentage of T, 10%. So answer is 25%. Okay, so it's 25%. Yes, this is how it works. 25%. Okay. So this is how your exam question is going to be. They'll tell you a story like H and T. Sometimes they expect you to look for the formula. You have to use your formula. You must look for a formula. Then use a symbol, write the uncertainty formula. Then you figure out what's the answer. Okay. So this is the today's class. Okay. So we're done with this second topic. Tomorrow we're going to do more questions about this topic. One lesson to do these questions. Okay. Which question we're going to do? Of course, this paper. Okay. We have plenty of questions from this past year's year. Okay. As a homework, I want you to give a try. The questions I want you to try is for everyone. We have altogether how many pages? About 33 pages. I want you to try the last few pages. 30 to 33. Okay, from where? Yeah, from 30. From here. June 10, paper 22. 30, 31, 32, and 33. Try these questions. Okay, answer is provided. So tomorrow I want the feedback from you. I want you to explain to me. I call your name, you just explain to me how do you done the question. Okay, kind of discussion. Good for you when you discuss. Okay, when I call your name, you just try to explain. If you can't explain, it's fine. You just give your try. I help you. Okay. Any questions for today's class?
June 10 what year?
Yep.
June 10 what year?
June 10.
Paper.
What is that? Page 30 onwards. 30 to 33. Page 30. June 10, paper 22 onwards.
Okay.
Page 32, 33. Okay, you do this question. I want a feedback next class tomorrow. Okay, 4 pages only one. Maybe you can spend around 45 minutes for today. Okay. So any questions for today's lesson?
No.
No questions, huh? Okay. So everyone can access to times, right? Anyone got problem accessing to times? Because I'll be putting a tutorial on times for you to do. So I'll show you next class, okay? But I can't show you how to access times because I'm from the staff ID. You are student, I don't know how you access it. Anyone got problem accessing to times, to the notes? Anyone? So all of you able to access, because I'm going to put tutorial in times. One small kind of like a quiz questions, 4 to 5. You try to do and you have to submit inside the times. Okay. So tomorrow I teach you where to find the tutorial. Okay. So if you don't have questions, we stop here for today. Okay. So see you all tomorrow. Thanks.